Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concept. Isn't that children? Okay, without wasting much time, let us start our session. Children, do you know what a ratio is? A ratio is an ordered comparison of two quantities. If A and B are any two quantities, then the ratio is written as A colon B. And how we read it children? Yes, we read it as A is to B. And children, do you know what a proportion is? Two ratios are said to be in proportion when they are equal. If we have two ratios A is to B and C is to D equal, then I can say A, B, C and D are in proportion. And again, if they are in proportion, we can write that product of means is always equal to the product of extremes. That is A is to B is equal to C is to D, then BC is equal to AD. So, here what are the means children? Yes, B and C are means. So, product of means B into C is BC and product of extremes are A and D. So, A into D is AD. So, BC equal to AD. So, children, apart from this, do you know what a compound ratio is? If A is to B and C is to D are any two ratios, then their compound ratio is given by AC is to BD. So, take a look at this situation children. So, consider a bank. Mr. Venkat wants to deposit some cash in this bank and he went to speak to the bank manager, and he thought that if he is going to deposit more amount, then he would be getting more interest. Isn't that correct children? Yes. So, whenever you are going to deposit more amount, obviously you are going to get more interest. Lesser the amount you deposit, amount will be less children. So, take a look at another scenario wherein there is sales going on and Miss Akila wants to purchase something. Okay. So, if the number of articles purchased decreases, then what happens to the total cost children? Yes, that also obviously decreases. Okay children. So, in our session today, that is direct and inverse proportion, we are going to learn more about these concepts. So, let us see the concepts children now. By the end of this session, you will learn of teams in the school. Let us see. So, if you notice these two, that is National Green Corps team and the number of saplings, if you notice the number of teams are increasing here 6, 7, 8, 9 so on. Now, what is happening to the number of saplings here? Yes, they are also increasing. As the number of teams increases, the number of saplings also increases. And children, do you find any relationship between these number of saplings required and also the number of teams? Let us see. I will find out number of saplings required divided by the number of NGC teams. Let us take the first one, that is 6th class. So, they require 60 saplings and how many teams are there? 6. So, 60 divided by 6. How much you will get children? Yes, 10, right. Now, what about 7th class? So, it is 70 by 7, that is also 10. That means, I can write 60 by 6 equal to 70 by 7. Now, take a look at 8th class children. It should be 80 by 8, that means that is also 10. So, I can write all these, that is 60 by 6, 70 by 7, 80 by 8, 90 by 9 and 100 by 10 all are equal and they are equal to 10. That means, in other words, I can say the number of saplings required by the number of NGC teams is equal to 10. That means a constant. So, always we are getting 10. So, that means number of saplings required for class 6 divided by the number of teams in class 6 are getting 10. Like that for 7th also you are getting same thing. So, we get always a constant. Okay children. Now, this 10 which is a constant, okay, so is given a special name actually. Okay. Now, this number of saplings and also the number of teams are said to be in direct proportion. But why they are in direct proportion? Because if one quantity increases, the other quantity is also increasing. If one quantity decreases, the other quantity is also decreasing. So, whenever this situation arises, we say that both the quantities are in direct proportion. So, the ratio is same, we call this variation as the direct proportion. And here the number of saplings required and the number of NGC teams are in direct proportion. Let us define exactly what direct proportion is, children. If x and y are any two quantities such that both of them increase or decrease together and x by y remains constant, then we say that x and y are in direct proportion. So, this can also be written as x proportional to y. So, you can see, children, here this is a proportionality sign symbol. Okay. So, I will read it as x proportional to y, and we read it as what, children? X is directly proportional to y. So, this is how we read, children, x directly proportional to y, or I can write x by y is always constant, right, children? On cross multiplying, what do you get? X is equal to ky, and this k I already told you is called the constant of proportion or constant of proportionality also. Okay, children. So, let us learn more about this direct proportion now. So, we have already seen x by y is a constant, right. So, if x and y are in direct proportion and y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then I can write x1 by y1 equal to x2 by y2. That means, here if you notice, this y1 and y2 are the values of y. Okay. Similarly, these values are what, actually corresponding values for x1 and x2. That means, for x1 we have y1, for x2 we have y2. We can write x1 by y1 equal to x2 by y2. Let us see some examples of direct proportion in our daily life, children. So, number of items purchased and the total cost, they are in direct proportion. Not only that, amount deposited in a bank and the interest earned, they are also in direct proportion. And time and distance. So, if the distance is more, the time taken is also more. If the distance is less, time taken is also less. So, they are said to be in direct proportion. So, let us solve an example, children, now. If the cost of 20 meters of a cloth is 1600 rupees, then what will be the cost of 24.5 meters of the same cloth? So, let us start the solution, children. So, here the cost of cloth as well as the length of the cloth, both are in directly proportional. Why? Because the length of the cloth, if it is more, then you need to pay more amount. So, the cost will be more. So, that is why when one quantity is increasing, the other quantity is also increasing. So, we say they are in direct proportion. So, let us tabulate these values. So, cloth I am marking it as x and cost as I am marking it as y. So, we have seen that the cost of 20 meters of cloth is 1600. Now, we want to find the cost for this 24.5 meters. So, its cost we do not know. What is the relation when they are in direct proportion? x1 by y1 equal to x2 by y2. Now, let us find out what are x1 y1 and x2 y2, children, here. So, x1 is 20 and x2 is 24.5. What about y1 and y2, children? Yes, 1600, and y2 value is what we need to calculate. Let us substitute these values in place of x1, y1, x2, y2. So, we get 20 by 1600 equal to 24.5 divided by y2. Let us cross multiply, children. Now, what do you get? The value of y2 is 24.5 into 1600 by 20. Now, let us simplify this, children. So, 20 goes 1 time in 20, whereas in 1600 it goes 80 times. Now, what is left, children? Yes, 24.5 into 80. On multiplying this, you get 1960. Hence, what do you write, children? Therefore, the cost of 24.5 meters of the same cloth is 1960 rupees. So, children, we have understood what actually a direct proportion is, and also we have solved an example on direct proportion. Now, let us move on to our next concept, that is inverse proportion. So, consider a scenario, children. Here a car is moving on a road and it covers a distance of 150 kilometers. Let the speed of the car be 75 kilometers per hour. So, how much time will it take, children, to cover that distance? Yes, it is distance by the speed. So, distance is 150 and the speed is 75. So, 150 by 75 will give you how many hours, children? Yes, 2 hours. So, the time taken by the car is 2 hours. Now, let us take another example of a bike which is covering the same distance, that is 150 meters, but the speed of the bike is 50 kilometers per hour. Now, how much time will it take, children? Yes, 150 by 50, which gives 3 hours. Now, what do you notice in these, children? Yes, we see that speed is increasing, whereas the other quantity time taken is decreasing, and vice versa, that means reverse of that. So, in such cases we say they are in inverse proportion. So, here we can say that speed and time are in inverse proportion. Now, let us take another scenario, children, where we are going to consider a manufacturing unit. Imagine that there are 200 workers in that company or an industry, and the time taken to complete is 5 days. So, 200 members work for 5 days to complete a given work. Now, let us see what happens when the number of workers gets decreased. So, we have 100 now, the number of workers, then the number of days is increased to 10. Now, further we decrease the number of workers, say 50. So, the number of days has increased to 20. Let us decrease the workers further 25. Now, what is happening here? Then the number of days has decreased to 40. Now, here if you notice, the number of workers are decreasing, whereas the number of days are increasing. So, I can say number of workers decreases and the time taken increases and vice versa. Now, let us try to see some relationship in these two children. So, I am marking the number of workers as x and the number of days as y. Now, let us multiply x and y and see we can get any relation or not. So, here the first one, that is 200 is the value of x and value of y is 5. Let us multiply them. How much you get, children? Yes, 1000. Let us move on to the next one, that is 100 into 10. You get again 1000. Let us move on to the third one, 50 into 20. Again you get back 1000. And final one, 25 into 40. Then also you get 1000. Now, what can you tell from this one, children? Yes, the product of x y, that means x into y is nothing but x y. So, x y is a constant. Then we can say that the number of workers and the time taken are in inverse proportion. Now, let us define what inverse proportion is, children. Two quantities change in such a manner that if one quantity increases, the other quantity decreases in the same proportion and vice versa. Now, this is called inverse proportion. If x and y are in inverse proportion, then we can write as shown on your screen. So, just like how we used for say direct proportion, children, the same thing, but when we are taking inverse proportion, we write it as 1 by y. So, x is inversely proportional to y, this is how we read, but here it is x is proportional to 1 by y also you can read, both are correct. Okay, children. So, x proportional to 1 by y or x is inversely proportional to y. Therefore, I can write x is equal to, if I remove the proportionality sign, I get some constant k divided by y. Now, let us cross multiply, children. What do you get? X y is constant, and again here this constant k is called constant of proportionality. So, if x and y are in indirect proportion and y1, y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then I can write x1 into y1 is equal to x2 into y2, or x1 by x2 is equal to y2 by y1. Now, let us see some examples of inverse proportion in our daily life, children. So, I can write time taken and the number of workers. So, as the number of workers increases, you can see the time taken is decreasing. As the number of workers decreases, time taken increases. So, this is one important example in our daily life. Move on to the next one, that is speed and time. So, as the speed increases, the time decreases. As the speed decreases, time increases. Again both are, you can see one is increasing, the other is decreasing. So, these two quantities are also said to be in inverse proportion. Let us take one example to understand this more clearly, children. A camp has food stock for 500 people for 70 days. If 200 more people join the camp, how long will the stock last? So, here if you notice, children, the number of people is inversely proportional to the number of days. So, read the question very clearly, children, because first you need to understand the question and see whether the two quantities given are in direct proportion or in inverse proportion. That is most important, children. Okay. So, read the question properly before you start the solution. So, here the number of people, say suppose here it is given, say 500 is the number of people and 70 days is the stock. Now, if the number of people goes on increasing, what will happen to your stock? It goes on decreasing, right. That means, when the number of people are increasing, the stock goes on decreasing. That means, both are in inverse proportion. So, let us tabulate, children. So, we have taken number of people as x and the number of days stock lasts is y. So, in the first case, when there are 500 people, we have 70 days of stock. Now 200 is increased. So previously there are 500, now 2 more 100 are added to that. That means what is the number of people now here? 700. So 700, and for 700 people, how many days the stock will last? That is what we need to calculate. So already they are in inverse proportion. So I can write x1 into y1 is equal to x2 into y2. Now let us see what are the values of x1 and y1 here. x1 is 500, you can notice here, and x2 is 700. Similarly, y1 is 70, y2 is what we need to calculate. Now let us substitute these values in these children. So x1 is 500, so 500 into y1 is 70 equal to x2 is 700 into y2, we don't know, we have to calculate. Now what is the value of y2 children? Yes, it is 500 into 70 divided by 700. Let us simplify this. So 70 goes one time in 70, and whereas in 700 it goes 10 times. Now 10 goes in 10 one time, whereas in 500 it goes 50 times. Now what is left children now? Yes, 50. That means the stock lasts for 50 days. So children, we have understood what are direct and indirect proportions, and also we have seen some real life examples of direct and inverse proportion, and we have solved few examples also. Now let us move on to our next concept, that is compound proportion. So sometimes change in one quantity depends upon the change in two or more quantities in some proportion. Equate the ratio of first quantity to the compound ratio of the other two quantities. That is, if A is to B and C is to D are any two ratios, then their compound ratio is given by AC is to BD. Now one quantity may be in direct proportion with the other two quantities, and one quantity may be in inverse proportion with the other two quantities, and one quantity may be in direct proportion with first one and inverse proportion with the second one. So these all are the situations for compound ratio. Now let us understand more clearly by taking an example. The mess charges for 35 students for 24 days is 6,300 rupees. How much will be the mess charges for 25 students for 18 days? So here there are three quantities: mess charges, number of days, and the number of students. So there are three quantities here. Now you have to find out which two are in direct proportion or which two are in inverse proportion, or whether you have one direct and one inverse proportion. Okay children, let us see. So here the three quantities are what children? Yes, the mess charges and the number of students, and as well as the number of days. Now let us tabulate them so that it is easy for us to see whether they are in direct proportion or inverse proportion. So first, the mess charges are 6,300 in the first case, where the number of students are 35 and the number of days are 24. Now we don't know the mess charges in the second case, so we will assume it as some x rupees. And how many students are there children in the second case? Yes, there are 25 students. And how many days are there? 18 days. Now if you notice, the number of students are decreasing than the previous one, and the number of days are also decreasing. Now let us find the ratios now. 6,300 is to x, 35 is to 25. You see 35 is to 25, convert this into simplest form. How? 7 is to 5. Last one also, that is 24 is to 8. Now here also if you notice, it is not in the simplest form here, 6 4s and 6 3s. So what do you get? 4 is to 3. Now if you notice, mess charges and the number of students are they are directly proportional. Why? As the number of students increases, what will happen to the mess charges? Suppose you went to a restaurant, you are alone, so 50 rupees. So if your friends are going to join with you, say suppose some 3 members have joined with you, that means total 4. Now 50 into 4, how much? 200 rupees. So as the number of people are increasing, the charges increase. Here also the number of students, if they increase, the mess charges also increases. So that means these two quantities are in direct proportion. I can write 6,300 is to x is equal to 7 is to 5, because they are in direct proportion. Now let us see the next one children, that is mess charges and number of days. Now what will happen to this mess charges and number of days? Here also if you notice, as the number of days increases, mess charges also will increase. So I can write 6,003 is to x is equal to 4 is to 3. Now I can write mess charges depends upon both the values here, that is number of students as well as the number of days. So what we are going to do is, we are going to take compound ratio of these two variables. Let us see how to take that. So mess charges proportional to compound ratio of the ratio of number of students and the ratio of number of days. So, we have calculated the ratio of number of days and the ratio of number of days also we have calculated. So, let us take the compound ratio of these two. So, that means 6003:x is equal to compound ratio of the number of students, that is 7:5, and the number of days, that is 4:3. And we have already learned, children, that is compound ratio of any two ratio, that is whenever we have two ratios, say A:(b) and C:(d). How to calculate the compound ratio of that? AC:(BD). So, let us calculate the compound ratio. So, 6300:x is equal to AC:(BD). So, here what is A? 7 and C is 4. So, 7 into 4. Just multiply them and see what do you get, children? Yes, we get 6300:x is equal to 28:15. And we have already seen that whenever two ratios are equal, we can write product of means is equal to product of extremes. Now, let us see what are means here. Yes, x and 28 are means. And what about extremes, children? Yes, 6300 and 15. Now, let us see multiplying these two. So, I get x into 28 product of means equal to 6300 into 15, which is product of extremes. Now, x value is equal to 6300 into 15 divided by 28. Let us simplify this, children. So, what is left, children, now? 225 into 15, and multiplying this you get 3375. Hence, I can say that the required mesh charges is 3375 rupees. So, children, I hope you have understood the concept of compound proportion. So, till now we have seen direct proportion, inverse proportion, and also compound proportion. Now, based on all these concepts, now let us solve few examples. So, let us start with the first problem. A loaded truck travels 14 kilometers in 25 minutes. If the speed remains the same, how far can it travel in 5 hours? Let us start with the solution. Distance and time both are in direct proportion, because more the distance, more will be the time taken. So, let us tabulate this distance assuming it as x and time as y. So, in the first case, distance travelled is 14 kilometers, so 25 minutes, and in the second case the time taken is 5 hours. Now, we need to calculate the distance travelled. So, since they are in direct proportion, we use x1 by y1 is equal to x2 by y2. x1 is 14 kilometers and x2 is what we need to calculate, and y1 is 25 minutes, whereas y2 is 5 hours. So, here there is a difference, one is in minutes, the other is in hours. So, what we do is we are going to convert hours into minutes. So, y2 is equal to 5 into 60 means 300 minutes. So, you need to be very careful, children, here, because the unit should be same. You cannot take one as minutes and other as hours. So, when we are comparing, that is whenever we are taking ratios, the units should be same. This already we have learnt in our lower classes, isn't it, children? So, now substituting the values, we get 14 by 25 is equal to x2 by 300. Let us simplify this, children. In 300, how many times, children? 12. So, we get 14 into 12. On multiplying this, you get 168. Hence, I can write, on multiplying this, you get 168. Hence, I can write that the loaded truck can travel a distance of 168 kilometers in 5 hours. So, let us move on to our next problem, children. A ship can cover a certain distance in 10 hours at a speed of 16 nautical miles per hour. By how much should its speed be increased so that it takes only 8 hours to cover the same distance? Let us start with the solution, children. Again, speed and time are in inverse proportion, because as the speed increases, the time decreases. Speed decreases, time increases. So, that means one quantity increases, the other quantity decreases. So, both are in inverse proportion. So, let us tabulate the values, children, as usual. So, I will take speed as x and time as y. So, in the first case, the speed is 16 nautical miles per hour and the time is 10 hours. Then in the second case, the time taken is 8 hours, we need to calculate the speed. So, again, since they are in inverse proportion, we use the relation x1 into y1 equal to x2 into y2. Now, let us consider the values of x1, y1 here and x2, y2. x1 is 16, x2 is what we need to calculate. Then y1 is 10 hours and y2 is 8 hours. Let us substitute these values in the equation. So, 16 into 10, that is x1 into y1 equal to x2, as usual same thing we need to calculate, into y2 is 8. Now, let us find the value of x2 from this, children. So, we get 16 into 10 by 8. So, 8 goes in 8 one time, whereas in 16 it goes 2 times. So, we are left with 2 into 10, which is 20. Hence, the speed of the ship is 20 nautical miles per hour. The ship has to increase its speed from 16 to 20 nautical miles per hour. We have already, it is given it is moving with 16. So, speed should be 20. That means, there is an increase of 4 nautical miles per hour. So, children, I hope you have understood the concepts of direct proportion, inverse proportion and also compound proportion. And we have seen some applications of these concepts in solving few problems. So, before we end our session, let us quickly recap what we have learnt. A ratio is an ordered comparison of two quantities. Two ratios are said to be in proportion when they are equal. If A is to B and C is to D are any two ratios, then their compound ratio is given by AC is to BD. Let us learn about direct proportion. Two quantities x and y are in direct proportion if both of them increase or decrease together, and x by y remains constant, and we represent it as shown on your screen. If y1, y2 are the values of y corresponding to the values x1, x2 of x respectively, then we can write x1 by y1 equal to x2 by y2. This relation we use only when the case of direct proportion, children. Now, let us see inverse proportion. Two quantities x and y are in inverse proportion if one quantity increases, the other quantity decreases in the same proportion and vice versa, and it can be represented as shown on your screen, children. If y1, y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then we can write x1 y1, that is x1 into y1 is equal to x2 into y2. Let us work out some problems at your home. Okay, you need to work out these problems in your home and send these solutions to your respective teachers. Okay, children, let us see the first problem. So, 25 bags of rice cost 87,500 rupees. Then find the cost of 32 bags of rice. 15 men can do a piece of work in 30 days. In how many days? 10 men can do the same work. 24 boys working at 8 hours per day can do a piece of work in 15 days. In how many days can 20 boys working at 9 hours per day can complete the same work? So, children,